Hello everybody and welcome back. Today we are going to be talking about groundwater and the water table. So far in our water cycle, we know that a part of the water cycle is either runoff or infiltration. So runoff leads to surface water, which is what we focused on last time. And now today we're going to talk about what happens to that precipitation if it infiltrates into the ground. So remember that infiltration, it's moving, it's being soaked into the ground, and it becomes groundwater. So groundwater, again, is just water that slowly moves through the ground through infiltration and eventually will return to the surface through springs and then flow back to the oceans and become surface water. So the groundwater that's in the ground is not stagnant. So what does that mean? It means that even though it's beneath the surface of the earth, it's still moving. So if we take a look at this picture here, our groundwater, when it rains, the rain and precipitation will recharge the groundwater beneath the surface, and the groundwater will move towards either a spring or an ocean area, and it will eventually rejoin the surface water. So we're going to talk about something called the water table, and this is just an image of what that is. We'll kind of define everything as we move along, but just simplistically, the water table is really the line at which there is groundwater. So it's like the tippy top upper limit of where there is groundwater beneath the surface of the earth. So there's a few different areas of the water table that we need to know about. The first one is called the zone of aeration. So if you think of like air as the air around us, it doesn't have water. So that's the unsaturated zone. So the zone of aeration is going to be the area where there is no water. And these are just the pore spaces are filled with mainly air. Again, so zone of aeration, there's air in the pore spaces between the soil and there's no water. The zone of saturation, if something is saturated, it's full. So this is also called an aquifer. This is where the pore spaces in the material are filled with water. So water within those pores underneath the surface is known as groundwater. So the water table itself is the upper limit of the zone of saturation. Okay, so it's just where the water sits underneath the ground. Okay, so the water table can actually move up when it rains or down during a drought. So let's take a look at what this looks like. So here, this line right here would be our water table. Okay, so the zone where there's saturation, meaning that all of the pores in the ground are filled with water. Okay, so our water table is that upper limit. Above our zone of saturation, we have an unsaturated zone or the zone of aeration. So again, there's no water in the zone of aeration. There is just air in between the pore spaces. And let me actually go back to this other image here. So here we have an image of both ground and surface water and our water table and unsaturated zones. So this dotted line here, where we see, again, the upper limit of the zone of saturation, this is going to be our water table. So our water table is just that line that separates the saturated zone where the water is and the unsaturated zone where the air is. Okay, so again, the zone of saturation is also known as an aquifer, and we'll talk about that in just a minute. Right here in the middle of this picture, we have a river. So this groundwater is emerging again in the river, and the river is actually surface water. So on this side beneath the ground would be groundwater. We've got groundwater under here, and then the river at the surface of the planet would actually be considered surface water. Okay. So the depth of the water table, so how deep the water table is, will depend on different conditions, depending on which area you're in. So stream valleys, so like in a stream valley area, the water table would only be a few meters deep, so not very deep at all. And in wetland areas, like we talked about, those swamps and marshes, the water table is going to be right at Earth's surface. So that means that in a swamp or a wetland area, when you walk out into the wetlands, you can see the water at the top. You would actually be able to touch it with your feet. So the water table would be up at the very tip top of the surface of the Earth. In hilltops or dry regions, the water table can be super deep within the earth because the precipitation isn't going to be infiltrating into the ground, and it won't be recharging the water table. So drier areas will have a deeper water table. And this water table can move. So this line here in a given area, it can go up when it rains if it's being recharged, or it can drop in drought or in dry areas because there's not enough precipitation to add to it, which can be an issue, which we'll find out a little bit later, for people who rely on wells to get their water. So we need to know about aquifers, springs, and wells. So aquifers are permeable underground layers through which groundwater moves. Okay, so again, the zone of saturation. An aquiclude is an impermeable layer of rock. Remember, impermeable means that water cannot pass through it. So the pore spaces are so tight that the water can't go through. So groundwater will tend to discharge, meaning come up out of the earth, where an aquifer and an aquiclude come into contact. Now let's stop and think about that for a minute and why that would happen. So as your groundwater is moving beneath the ground, if it comes to an aquiclude where water can't pass through, it's going to have to go somewhere because the water is still flowing and there's still pressure behind the movement of that water. So if it comes into contact with an aquiclude and it can't pass through it, it's going to be forced upwards out of the surface of the earth and then become surface water. So when this happens, we get a natural discharge that's known as a spring. So there are two types of aquifers. There's unconfined and then there are confined. So this is kind of a graphic organizer of the difference between the two. So let's just kind of dig into this and then I'll explain it on the next page. So an unconfined aquifer means that the water rests on an impermeable layer, but it is open at the top, basically. So that means that the water will come down, infiltrate from the water cycle. So it will rain, the water will fall beneath the surface and infiltrate, and there'll be a impermeable layer that stops the water, and so the groundwater will be able to collect. Okay. In an unconfined aquifer, these are actually more at risk and exposed to pollution because the precipitation and any kind of debris or pollution can just sink right down into it, right? There's nothing on the top protecting it. It's just kind of like an open top. So if you think about like a glass of water, if you poured yourself a glass of water, the bottom of the glass stops the water from going through, right? But you can still drink out of the top of it because the top of the glass is open. That's like an unconfined aquifer. Now, on the other hand, with a confined aquifer, this is when water is trapped between two impermeable layers. So the water will eventually become pressurized, and it cannot be refilled from rainwater because the rainwater is not able to get down into the ground. So let me see if I can explain this a little bit better using this diagram. So here is an example of a confined and an unconfined aquifer. So if we look on the top first here, this is an unconfined aquifer. So it's open to infiltration and pollution. So here is the confining bed. So this would be that impermeable layer, probably made of clay and rock. So we have this confining bed here, which is impermeable. Then you have your unconfined aquifer, and it's open. So this area right here would just be soil. Okay, so the water could fall down from precipitation, infiltrate straight into the ground, and recharge this aquifer because it's unconfined. It's like a glass of water. It's open and it is exposed. On the other hand, below here we have a confined aquifer. And it's confined, if you think about being confined, like maybe in a closet or like a really small space. It's confined because it's between two impermeable layers, all right? So it's a lot harder to pollute a confined aquifer, but it also cannot be recharged by rain. All right, so the rain is not going to be able to recharge this area because it's not going to be able to seep through to the top because it's not open. So just to recap, unconfined aquifer only has one impermeable layer, and then the top is open, and then a confined aquifer comes between two impermeable layers, and it will become pressurized and a lot of times naturally emerge at an artesian well. So again, springs typically come up where an aquifer will meet an aquiclude. So the groundwater will run into an area where the layers are impermeable and kind of just get forced upwards to form a spring. And these can occur in different places, such as in the sides of valleys or the edges of water tables near the surface. The volume of water varies from the flow of a small spring to the rush of a large river. So depending on how much water is actually present in terms of volume or how quickly it's moving, you can have kind of more intense or a little bit of smaller spring. And this is just going to be kind of an example of the emergence of a spring. So this would be our groundwater that is flowing underground, and then eventually it will get to a point where it is forced up and out into surface water. And so the final thing we need to talk about today are wells. So wells are just holes that are dug or drilled into the ground to reach a reservoir of groundwater. Okay, so the groundwater is underneath the surface, and some people who don't have access to like city water, they will need to drill a well in order to access the groundwater so that they can have drinking water and water for household activities. So to produce water, a well has to tap into an aquifer. So it's got to get into the water table. So you'd have to drill down deep far enough that the well actually penetrates the water table. So here are some examples of wells. They have to be dug down into the aquifers to where the water can be pumped up. So the simplest wells are those that are dug or drilled below the water table into the zone of saturation. So remember, the zone of saturation is where the water is, and into what is called a water table aquifer. So there are two different types of wells. There's a typical well, which is just dug into an unconfined aquifer. So the top is exposed, you can dig the well out, and you can pump the water up. Now, with a typical well, you do have to pump yourself because the water is not naturally pressurized. On the other hand, you can have something called an artesian well, which sounds a little bit fancy, but an artesian well is drilled into a confined aquifer. So you've got those two layers of that impermeable rock, and the water is pressurized. And since the water is naturally pressurized, oftentimes that water will rise on its own. So an artesian well is in a confined aquifer, and you get natural pressurization of the water. And then a typical well is just dug into the water table that is unconfined, and you have to pump it yourself. And again, this is just an example of an artesian well. So because the area of recharge is usually at a higher elevation, a confined aquifer contains water under pressure. Okay, so water under pressure will create an artesian well. So when the rate of recharge is high enough, the pressurized water in a well drilled into a confined aquifer may spurt above the land surface in a fountain called the artesian well. So, and a spring that discharges pressurized water is called an artesian spring. So, really the difference between an artesian well and an artesian spring is that a well is man-made, so we've dug it specifically to get water, and then the spring will be a natural occurrence where that pressurized water comes up and out. Okay, so the major takeaways are that we need to know the differences in the water table. So we need to know where the zone of saturation, the zone of aeration is. And we need to know how springs come to be, and also the difference between our two types of wells. Okay? If you have any questions, let me know. And if not, I will see you guys in the next lesson.